Hi everyone, this is G.Sangeetha Lakshmi, Assistant Professor and Ed, Department of Computer Science and Applications, Deccan College, Vellore. I'm here to deliver a lecture on the topic 8085 instruction set. Microprocessor 8085 is a programmable device where we can feed the inputs to the device and the input is being processed and produces an output. Here, the binary data is acting as an input. To perform an action on the given data, some instruction set is needed for the processor. So, the microprocessor 8085, it has a set of instructions. Even that instruction is a binary pattern designed inside a microprocessor to perform a specific function. So, all those instructions together is called an instruction set for the microprocessor 8085. So, totally it has 246 instructions, since because 8085 is a 8-bit microprocessor. So 8-bit microprocessor, it tells that at a time it can process 8-bit data. So each instruction set is represented by an 8-bit binary value because of that. And each and every instruction inside 8085 has two parts. The one is opcode and other one is the operand. The opcode is nothing but it gives the instruction name, whereas operand tells the two content which acts as a source and which acts as a destination. Here, the instruction set is being classified into 5 different types. The one is data transfer instruction, the other one is arithmetic instruction, and next one is logical instruction, the following is branch instruction, and the last one is the control instructions. Now in this lecture, we are going to see in detail about data transfer instruction. As the name tells, it transfers the data from one location to the other location. Here inside the microprocessor, we have several registers and the memories. Some register acts as a general purpose register and some register acts as a special purpose register. So here in this instruction set, that is especially the type data transfer instruction, the data is being transferred between two registers or between memory to register or register to memory. In some special cases, directly an 8-bit data is being transferred to the specific memory locations or else to the register. Yes, these instructions set, as I said, it copies the data from source to destination. Here, the destination part, either it can be a register or memory. Whereas in the source part, either it can be of register or it can be of memory or it can be directly the 8-bit data itself. Fine. Though we are copying the content from source to destination, the source content is not being modified. The copy of the content alone is being transferred to the destination. Yes. We'll go in depth to the data transfer instructions. It contains 13 different types of instructions under this category, data transfer. The first and foremost is move instruction. Here the general format is given. As the name tells, it moves the content from one particular location to the other location. The location can be, as I said earlier, it can be from one register to the other register or from register to the memory or from the direct data to the memory locations or the register. Here the explanation is given. As I told, the source content is not being altered. For example, here it is given that move B, C. Here, the last one, the second, this part acts as a source and this part acts as the destination. This instruction tells that the content of C register is being moved to the B register. So, the content, whatever is available in C register is being placed inside the B also. At the last, the content of C register is not being altered. Only just transfer it. It takes a copy of the content. Okay. So, yeah, in general instruction it is given that move, either the two things can be of registers or memory or register or memory and register. So, this, as I said, it is given in the 3 different parts. And next one is move immediate. As I told you, the source event, a direct data can be acted as a source. It is not that only the registers or memory have to act as a source. As I told you, here the data has been acting as a source and that data has been transferred either to register or to the memory. So two different types of general format is given here. The direct data, the 8-bit data is transferred to the register or the direct data has been transferred to the memory location. The memory, once it plays the word memory in 8085, it tells it has been represented by the HL register pair. That is, the location is being noted from the register HL pair. Yes. The example of this instruction is given below, that is move immediate MVI B, 57. Here the 57, the 8-bit data is being transferred to the register B. Here it is given MVI M, 57. In this example, the data, 8-bit data 57 is being moved to the memory location whose address is given by the HL register pair. So whenever we use the memory M in 85, the location is being represented by the HL register pair. Yes. And next instruction is LDA instructions. Here, this is the opcode part, that is LDA, the instructions, and the next one is the operand part, 16-bit address. The instruction tells that it loads the content from the memory location whose address is given by this 16-bit address, and that content is being loaded to the accumulator. Accumulator is a special register where in 8085 all the output is being stored in this specific register. That is what it is named as accumulator. This LDA instruction tells that the content of the memory location specified by the 16-bit address is being copied to the accumulator. Fine. And the next one is LDAX. Here, instead of giving 16-bit direct data address, here they are representing the register pair. In 8085, we have 6 general type of registers, that is B, C, D, E, H, N. Here, certain combination of registers will be acting as a register pair, that is BC, DE and HL. Such register pair can be noted here. If you are using B, it is understood implicitly that the register pair name is BC. If you are denoting the letter D, it is understood that the register pair is DE. Here in this instruction it is said that LDAX, the register pair name. So this is operand part, this is opcode part. As I told you, the instruction contains 2 parts. One is opcode, the other one is operand. Here the content of the designated register pair pointed to the memory location that is being transferred to the accumulator. That is, the content from the location where the address is given by this register pair is being transferred to the accumulator. Here the example is given LDAXB. This is said that the content from the memory location whose address is given by BC register pair is being transferred to the accumulator. And next one is LXI. As the letter I comes in the opcode, tells that here the source acts as the data. Fine. See here LXI. Here the instruction loads the 16-bit data into the register pair. The example is given as LXI H2034. This 16-bit data is being immediately loaded to the mentioned given HL register pair. Here the least bit is being loaded into least register, that is L register, and the most significant data is being loaded to the higher order register called H register. So the content is being transferred to the HL register pair. And the next instruction is LHLD. This instruction copies the content of the memory location pointed by the 16-bit address into the register L. That is, it loads the content. It loads the content from the address first to the L register and it increments the memory location, and from that location it takes the data and transfer the content to the register H. See here, the example is given LHLD 2040. The 2040 represents the 16-bit data, it represents the memory location. The content from this location has been transferred to L register and the memory location has been incremented, and from that location the content has been transferred to H register. Yes, we'll move on to the next instruction, SGA. So far we have seen move instruction and the load instruction, and next follows the store instruction. Here the content of the accumulator is being copied into the memory location specified by the operand. Here the 16-bit address itself, it's given directly instead of giving the register name and the memory. Here the 16-bit data itself given. So it represents the address of the location inside the memory. In that memory location, the content of the accumulator has been copied. Yes. We'll move on to the next instruction, STAX, register pair. Here, instead of giving a 16-bit data, here the register pair name is given. This tells that the content of the accumulator is being copied into the memory location whose address is being given by the register pair. For example, see, here the instruction is given STAXB. Here, this instruction tells that store the content of the accumulator into the memory location whose address is given by the BC register pair. As I said, when the name register pair, here inside the instructions we noted that the X symbol is given. Once the X symbol comes under the instruction, under the opcode, it is the particular register is being noted as a register pair. So by default, when I have given a name B, it is understood that implicitly it has been considered as register pair. So it combines with the C register, it acts as a BC register pair. So the content of the accumulator is being transferred to the memory location whose address is given by the BC register pair. And next instruction is SHLD. Here, it stores the content. See, the content of the register L is being stored into the memory location whose address is given by the 16-bit address there in the operand part. And the content of H register is being copied to the next memory location. For example, see, it is given here SHLD 2550. Here, the content of L register is being stored to this specific address and the content of H is being stored to the next location of this address. Yes. We'll move on to the next instruction. Here comes the exchange, XCHG. Here in operand part, nothing is given because once the opcode is being noted, means this instruction can take place only between two register pair, that is HL and DE. It tells that, the name tells that it can exchange the data between HL and DE register pair. See here, the content of register H is being exchanged with the D register and the content of L is being exchanged with the E register. And next one is PCHL. It loads the program counter with the HL content, that is the content of registers L and H are copied into the program counter. Program counter is a special register where it tells the memory location to the microprocessor, that is, this is the next location to be fetched for the instruction. That's it. The data transfer instruction is over. Thank you.